guys graphed just exponential functions that had a base, and then the exponent was your variable that you plugged in for your table. Now today we are adding some numbers to the exponent, and we're adding a constant after the exponent, after the exponential part. And these values, do you guys remember, like whenever we had vertex form for a parabola, we always did like the opposite of the x and then the same sign as the k to find the vertex? You'll tend to find that in almost all graphs, we always do the opposite of the x and the same sign for the y. So those values do still affect the exact same way. So whenever you have an x in the exponent, today we're either going to have a number added or subtracted to the x. So you might see in the exponent today like an x plus 3 or an x minus 4 or something like that. If you see a number being added or subtracted, that affects the x-axis. Now, doesn't the x-axis go from left to right? So wouldn't that make sense that if you're adding or subtracting a number to the x, it's going to make the graph move left or right? And we always do the opposite. That's why it has a minus in the formula. So if you see something being added, it's going to shift that graph to the left. If you see something with a minus, an x minus a value, it's actually going to shift the graph to the right. And then if we add a k value, so if there's a number being added or subtracted after the exponent, if something's being added, it affects the y-axis, which is up and down. And the y-axis, you always see the sign, like a positive means it's going to move a point up, and if it's negative, it's going to move a point down. So in graphing, we always have something that we call the parent function. The parent function just means it's like the most simple function that you can have. And then all of these shifts are things that are added or subtracted or multiplied. In Algebra 2, we actually add a coefficient in front as well and make it expand or shrink. But today we're just going to focus on left and right and up and down movement. We've done this with absolute values, we've done this with parabolas, and now we're going to do it with exponentials. So we've done this a lot with the h and k values. Now, we're going to graph today in 3 steps. So the parent function here is just where nothing's being added or subtracted. The parent function is just the base and the exponent. So the very first thing that we are going to do is we're just going to make a table like we're not adding or subtracting anything. And then we are going to make a graph of that parent function. And maybe I should have put y equals in front of it. All right, this a to the x is what, if you ever hear me call it the parent function. So a parent function just means it's a base, and then, you know, anything added to it just makes a shift. So we're going to graph the base, and then we're going to use the numbers in the equation to tell us, like, does it move left and right? Does it move up and down? And then we will make those moves to the points that we have on the graph. So that's the reason why I had you guys grab 2 colors of colored pencils. You guys, I'm just grabbing some extras because I'll probably write a little bigger than you do. All right, are we ready to start our first example? All right, we are actually going to graph this. Let's see how this black and white feature looks. It's not the best, but it works. All right, so we have got 2 to the x plus 1 power and then a plus 3. And so you'll want to make room for your table. And then we're going to make a graph, and let's go from so let's go from -6 to +6 on the x-axis. And let's see. And go from 0 to 14 on the y. All right, so I'll give you guys some time to make that graph. Do that with your pencil. All right, so we are going to graph the parent function first in one color, and then we're going to decide what the shifts are going to be in the second part, and then we'll move our points. So if we look at this, the parent function is just the base and the exponent of x. So what's the base? The base is always the number that's being raised to a power. So what's the base? The base is 2, and the exponent is x. This right here is your parent function, your base and your power. Now this +1 and the +3, that's telling us how to move these points later. But the original function is just 2 to the x. So you guys should have made tables for these yesterday. Do you guys want to start with positives or negatives? All right, so I'm going to go let's see, what's the highest power? 2 to the 4th goes off the graph because 2 to the 4th is 16. So I'm going to start out at +3. What is 2 to the 3rd? So 2 to the 3rd power would give me what? 8. All right, so then 2 squared would be 4. 2 to the 1st would be 2. What's anything to the 0 power? That is 1. Now, -1. When I plug in a -1 for the exponent, that now creates a fraction, right? What is 2 to the -1st? 1/2. And -2, 2 to the -2nd is 1/4. You'll say, I don't like to graph a ton of fractions, just enough to get the shape of the graph. So what we are going to do here is we are going to graph this in whatever color you would like to start out with. Now I'm going to graph it in pencil just so it doesn't show up as bright as this marker. So the first, I'm going to graph the point 3, 8, 2, 4, 1, 2, 0, 1, -1, 1/2, and -2, 1/4. So those little points from the table. Now this is not our final answer because we've not included our shifts yet, but this just gives us an idea of where to start. So I'm going to go over to 3 up to 8. And then I'm going to go over to 2 up to 4. Over 1 up 2, 0, 1. And then 1/2, 1/4 would be a little bit less than that. Now I'm not going to connect this. This just gives us a starting point. Yes, so pick a color. So I just used pencil so that way it would be a little bit lighter. I don't really have the option to do the color here in my black and white mode. Whenever I go to color mode, it's hard for you guys to see up on the projector. So I'm going to do pencil and marker to distinguish the two. All right, so this is what the graph would look like without anything being added or subtracted. So that is just for this part. So now we have two numbers. We have a +1 and a +3 that adjust how this moves. So in this case, the +1 affects the x-axis. It tells us that we're going to move left or right. So based on what we wrote in our notes, if it is a +1, does that mean go 1 to the left or 1 to the right? If it's a +1. All right, we always do the opposite of what we think. So if it's a +1, it actually goes in the net, like it always goes in the opposite direction. So we are going to move every point. This graph right here tells me I'm going to go 1 unit to the left for every point. Now this +3, this tells me how to move up or down. So does a +3 tell me to go up 3 or down 3? Up 3. So now that we know how to move, this is where we're going to take our second color, just so you can see the difference between the two. Every single point that we have graphed to get the actual graph we're looking for, we are going to start from that point, and every single one we are going to go left 1, up 3. So this first point, left 1, up 3, and there we go. The second one, left 1, up 3. The next point, left 1, up 3. Left 1, up 3. Left 1, and these fractions, it's a half, so up 1, up 2, up 3. I'm still in between points. And then this one's a fourth, up 1, up 2, up 3. So not quite, a little bit less. So on this one, yesterday none of your graphs crossed 0. Here, this is our value of 3. So however much we move up, you definitely don't want your line to cross that line. So everything's getting really close to the value 3, but never crosses it. And then once you move all of those points, then you can make your graph. So we start out with the base, get a baseline, get our points ready, and then follow the shift. So if it says move to the right 2 and up 1, we would go right 2, up 1. Just follow what the numbers tell you. Now, I do want you guys to see this kind of in different steps at a time. So let me pull something up for you. You guys don't have to open this up. All right, so the first thing that we made a table for was 2 to the x power. And you had something that looked, this is what you graphed, just the dots, but we didn't connect the line. So then you can see when you add when you add the 1, look at what happens. Oh, that's not what I wanted to do. Add it up here. Why won't it let me? All right, I had to put it in parentheses. So do you see here how this point here got moved to the right or to the left 1? This point here got moved to the left 1. Everything just shifted over 1. So then whenever I add, the +3, it now shifts all of those points up 1, 2, 3. So we're taking out this middle step. So what we're doing is we're just graphing the parent function, and then if you can see here that first point, which 3, 8 is off the graph, but let's go. One of our original points we graphed was 2, 4. It was right here, and so that was the original, but the shift went to the left 1 and then up 1, 2, 3. There we go. That point corresponds there. So these are exponential functions, and then it kind of levels off at the end. So we're going to do a couple more. And let's do one with a fraction next. All right, so let's go back to our graph paper. And we'll say I've got room here to make another one. Oh. Sorry. You have erasers, I don't. All right, so 1/3 is our base, and then our exponent is x plus 2, and then we've got a -5. All right, so what are we going to make our table for? When I go to make my table, what's the parent function? What would it look like if I didn't have any shifts there? Well, yeah, what's the base? What's the base? So like on that last example, our parent function was just the base and the power. The last one, our base was 2. What's our base on this one? Our base is 1/3 to the x. We'll deal with the +2 and the -5 in just a little bit. All right, so do you guys, yesterday, you can make a table for either one of those. Those two things mean the same thing. 1/3 to the x, or you can make it a negative and flip that fraction into a whole number. All right, so on this one, anytime you have, if you change this to a negative exponent, I would recommend making negative numbers first. Why do you think I would want you to do that? What happens when you plug in a negative number to a negative? All right, so let's start out with -2. So 3, if you have 2 negatives, it just becomes 3 squared, which is 9. -1, it would end up being 3 to the first, which is 3. Now what's 3 to the 0? 1. And then 3 to the negative first is 1/3. What's 3 to the negative second? 1/9. So we can make a graph for this. So my biggest value here, before we make this graph, I want you guys to take a look at something. Your graphs will be provided for you on your assignment. But if we are making our graph on our own right now, our shifts here, what's that +2 tell me I'm going to do? Which direction, left or right 2? All right, I'm going to go left 2. Now this -5, what's that going to tell me to do? Down 5. So here, we see some numbers that are really close to 0, but we know we're going to move all of those down 5. So whenever we make our graph, we're definitely, oh, I didn't even make a straight line. Hang on. You're going to want this to be more in the middle because you're going to go from -1, 2, 3, 4, 5, 6. You're going to have to graph some things in the negatives because we are shifting down. All right, so I've got my graphs. All right. So the first thing I'm going to do is I am going to graph my parent function. So my first, oh, I probably need to put these in. All right, so my first point is -2, +9. Then -1, +3, 0, 1, and then I got a 1/3 and a 1/9. Really close to 0. All right, so then once I have those points, everything that we are going to make is going to go to the left 2 and down 5. So that very first point up here, I'm going to go to the left 2 and down 5. So that took care of my first point. My second point, I'm going to go to the left 2, down 5. My next point, to the left 2, down 5. To the left 2, down 1, 2, 3, 4, 5. And it's getting really close to that down 5 or -5. But never crosses it. And this one, we've got some exponential decay. Hello. Okay, I'll let her know. All right, bye. Hey, Alaska, you're leaving. All right, so do you guys have any questions on this? You know, say, I know it's time consuming, but I don't feel like it's super difficult. You know, say we just have to remember our direction, so use those notes. But do you guys want to do one of the homework assignments together? Like one of the homework problems for today? Oh, let me see. What do we got going on today? Let's do number 4 together. All right, so while you guys are getting that out and getting number 4 ready, I'm going to go ahead and copy it down on the graph so that way I can write and the virtual students can see this as well. really need to learn how to draw straight lines. All right, so for number 4, we have something that looks like this. All right, what's our parent function there? What's the base? All right, 3 to the x. So this is what we want to make our table for. All right, so if we want to start making this, we all know 3 squared is 9, but what about 3 to the third? Would that fit on this graph? 3 to the third is 27. That's too big. You could put it on your table, but if it's too big, you don't graph it. But let's just go 3 squared. So we are graphing 3 to the x. So 3 squared is 9. What's 3 to the first? 3 to the 0. 3 to the negative first. 1/3. What's 3 to the negative second? 1/9. So that's your base. So we would graph 2, 9, 1, 3, 0, 1, and then we got our 1/3 and our 1/9. We got our little fractions over here. Going down close to 0, but not crossing.
What do you want us to get these colored pencils?
I'll give you instructions for those in just a second. But if you guys take a look at this, on our shifts, if you look up in the exponent, is there being anything added or subtracted to the x? So if there's nothing added or subtracted, are you going to move left or right at all? All right, so on this one, there is no left or right shift. But what does this shift tell us to do? That goes down 1. So every single point that you just graphed just needs to get moved down 1. And one thing that's nice about graphing on the computer, you guys can graph one. You can graph your original like in blue and then graph your second one in red and then connect those. So you guys do have the option to do those multi-colors on your assignment, and the graphs are already made for you, so it should be a little bit easier to graph here. And say, do you guys see anything else that's, I wanted to make sure that you saw one that didn't have a shift. So the front page, like on the first 2, you have things changing x, but there's nothing changing y. Here, the third and the fourth one, nothing changes x, you just have numbers changing y. And then on the back side, you have both shifts. So it's a little bit of everything. And this is the last lesson. Indicators 27 is super short. So I do want to let you guys know that we are going to review tomorrow, And then the quiz on Thursday will be super short. So if you guys do have like a quick question on Thursday before we start, we can do that. But if you guys have questions tomorrow, utilize the e-learning. If you have questions over either one of these assignments, you got to contact me before 3 o'clock, because after 3 o'clock, I'm going to be on the go all day tomorrow. My kids have lots of stuff going on. So if you email me after 3, I can answer, but I probably will not be available to do any sort of like Google Meet or anything. But one thing that is nice about Cami is if you guys have a question on something, you can submit it before the due date, and you can do a Google Meet and I can see your screen. And I can write on it and you can write on it and we can both see it. So if you guys have questions at all tomorrow, make sure you ask. I think the only thing I got going on is a quick meeting at 8 o'clock, and that's it. So the rest of the day I will be in here. So if you need me, just let me know. But otherwise, you guys can work. Colored pencils,